Hello everyone, and welcome to our lesson on Chapter 5 Proofs. I know that y'all are so excited to be talking about proofs again, but this is just something that we're going to continue to practice because proofs are like a language, y'all. Honestly, they're challenging for a lot of people, and so we're going to continue to practice this, and I figured it would be good to just have a lesson where we just prove triangles congruent using each of the shortcuts that we've talked about before. So remember that our 5 shortcuts that we've already studied for proving triangles congruent are side, 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 angle, side, angle, side, angle, that's the reverse. And then where the side is not included, it's non-included. And then the one that is specific to right triangles for hypotenuse leg. So those are, I like to call those the core 4 plus 1 because the last one only works for right triangles. Of course, we're not going to have a hypotenuse if we do not have a right triangle. So this is just something we're going to continue to practice. Our question today in class was, what is an uninteresting fact about you? So if you're watching this later, if you're sick today, just comment below what your answer to that question would be. And so I've given you 5 proofs here, and there are 5 of the shortcuts. So this is just to continue to practice proofs and to get you used to them. So what we're going to do first is we are going to look at the very first picture. Let's see. Oh, and my uninteresting fact is that I was born without wisdom teeth. Not that interesting, but kind of cool because I didn't have to have surgery. So very nice. All right, so let's look at, I always tell my students, let's look at what is given first because those are free points. Sometimes they'll put these together in a proof and then sometimes they'll break them apart. It really just depends on who's writing it. They do that for different reasons. So the first thing I'm going to do is acknowledge everything that's given in each of these proofs just so that you can see the general setup. It looks like they broke them apart mostly. And so I'm going to go ahead and highlight everything. Y'all know I'm a huge color coder, so it really helps me to just kind of see the general setup. So the first thing we're going to do is acknowledge that all of that stuff is simply given. Like when I put a reason for each of those, let me click undo. When I put a reason for each of those, all I'm going to do is I'm just going to write what is given. So all of those were just my givens. If those are not already marked in the diagram, you need to go ahead and add those markings. A lot of times my students will get stuck because they forget to add the congruence marks from the givens, and then that makes it almost impossible to read the diagram or to read the triangle in order to pick the shortcut. So all of these are going to be given informations. So those are free points. Don't leave those blank. If you're going to prove something, you have to start with something. And so all of that is given, and it's given for a reason, okay? And then what we're trying to prove on every single one of these proofs is that the triangles are congruent, so that the 2 triangles in the picture are congruent to each other. And you can see that that is where you wind up in the proof. That's like your end game. And you're trying to figure out which shortcut is going to go, or reason is going to go next to each of these in the proof. And so we don't have to use CP/CTC in any of these proofs because we're not proving any of the corresponding parts congruent. We get to just stop short and say, hey, these triangles are congruent by the shortcut. And so if I always have my students start by just looking at it. Let's first make sure that this stuff is marked in the picture. LM is congruent to NP. Yes, that is already pre-marked for us, thankfully. So if not, you'd stop and add it there. And then LP is congruent to NM. Both of those have 2 tick marks, so I know that those are congruent. So there's nothing I need to add so far. Right now, that's everything that's given. And so if I were to simply give you this diagram, many of you would actually probably be able to tell me that I need to add a side. These 2 triangles are touching or overlapping at a side length. And I'm going to mark that as congruent because if I broke those 2 triangles apart, if I literally split them apart, both of those would have that exact same side length in it. And that is the reflexive property. So many of you would already be able to see these 2 triangles are congruent by the side, side, side shortcut. But what we're doing in a proof is we're showing people why this is valid. Why can we use side, side, side? Well, we have to add this middle step. So let me change colors here. Adding this middle step right here allows me, that is not a highlighter. Adding this middle step right here allows me to say, what other information could I add that was not already given that would allow me to prove these triangles congruent using the side, side, side shortcut? Many of you can already see that it's going to be side, side, side. Well, we have to show that those two letters that create that side length are congruent to each other. So they say that L to N is congruent to N to L. Many of my students get confused on this part because they're like, well, when is it LN is congruent to LN and when is it reversed? Well, if you can look at this triangle, you can tell that it's been rotated. This one side has been turned around. But if you can't see that, that's no big deal. you can always look at the congruence statement if it's written. You can kind of cheat if this is given and say, okay, well, this is LN. So in this statement, LN is first and then third. So its corresponding pieces in its congruence statement would be first and then third. So that's why it goes into L. It has been rotated. And that is a property that we call the reflexive property of congruence. I know that that is a property of congruence because this is a congruence symbol. And as soon as I have that extra piece of information on here, then this is a side, and a side of one triangle, congruent to a side, and a side of another triangle, and then boom, triangles are congruent, and that is exactly what I wanted to prove. So that is my very first, one that I have done. Let me change to here. That is my very first one that I have done, and now we're gonna keep going. All right. What I want you to notice on this next proof is that I don't have any information marked in my picture. While I do have things that are given, I have not added that to the diagram. So that's always the first thing that we're going to do. We're going to add some information to the diagram. So it says that WV is congruent to Z to V. So I'm going to check that one off. It says that X to V, so I'm going to do 2 tick marks to show it's different, is congruent to Y to V. So I'm going to check that one off. And then it wants to know why these triangles are congruent. How do we get there? Well, if I were to just zoom in on the diagram, right now this is not a shortcut, but we know that these triangles are overlapping, similar to how my previous triangles were overlapping at a side. These triangles are overlapping at a point, and these segments create vertical angles. Vertical angles, it kind of is like a bow tie. It looks like a bow tie. And there's a vertical angles theorem that says vertical angles are congruent to each other. So I get to add that. Whenever you add that in the picture, we also need to add that in the proof. And they actually kind of told you where to go here. The vertical angles theorem would allow me to say that these angles are congruent. And so when I name that, I do have to be careful, because if I name this angle WVY, or WVX, let's go ahead and write that down, WVX, when I name the other angle to say that it's congruent to it, I need to name it in the same way. So notice that I went across the side that had 1 mark and then across the one that had 2. So this has been rotated, and so I need to do the same thing. So Z to V to Y, ZVY. So that would be congruent to angle ZVY. But similar how we did to the reflexive property, especially when you already have a congruent statement written, you could always name the first one however you want to, and then just find the corresponding pieces in the congruent statement. So you can always kind of use this to check it. We went WVX, which is first, second, third. So if I want to name the other angle in the same way, it would be first, second, third, which is ZVY. So you can, especially if that statement is there, use it. And so once I know that those angles are marked congruent, this is the side angle side shortcut. Side angle side. So that is our next one. We have now done a side angle side. I don't know why I keep grabbing the wrong one. Y'all, this is a new iPad, so I'm struggling. I'm still learning it. Okay, so now we've done one of each of those. Now let's look at what's given on this next proof. Now, thankfully, I have, similar to the very first one, I have a lot of markings already in the picture. So let's look at what's marked and what's not marked. It says that BA is congruent to BA, so that's side length. That's given. So I'm going to put a little dot there to show that's already there. It says that CBA, so let's go here, CBA and DEA are right angles. Thankfully, that's already in the picture as well. And then I think that's all that it has so far. Okay, cool. And so now we want to prove that those triangles are congruent. You can see that they already have the vertical angles marked as well. We'll come to that in a second. But I want you to see how they list this. This is interesting. They go and they say, okay, these are right angles. And then they tell you the next line, the reason is that all right angles are congruent. Well, if all right angles are congruent and they just told you the 2 that were right angles, we're on this step going to say that these are going to be congruent to each other. Angle CBA is congruent to angle DEA. Because if those are both right angles, then we know that they are congruent to each other. All right. Why then do they have this marking on CAB, angle CAB, which is this one right here, and angle DAE? Why are those congruent? It tells you that that step in the proof is one of the statements. We know from the previous problem that that is the vertical angle theorem. So you can always, when you're looking at these, if you don't know the answer to the proof, you don't know exactly what to write, like maybe you knew that those were vertical angles, but you didn't know that there was the vertical angle theorem, look at previous proofs and see if maybe that reason is filled in on any of them. Obviously, if you're filling out one completely by yourself, that is going to be a little bit harder, but that's called the vertical angle theorem. All vertical angles are congruent to each other, so that's why we're able to add those angles right there. And now this turns into the shortcut. This shortcut is the angle side angle shortcut. So it just has the reason next to the shortcut. So we have done one of each of those. So got that one right this time, y'all. Okay, so this very, very next one, this is interesting. This one, the first thing I noticed is that this does not say right here in the given, let me go a different color. This does not say congruent, so this middle stuff I'm gonna do in pink. This was the middle stuff that allowed me to get to the end. This was the middle stuff that allowed me to get to the end. I'm gonna keep doing that on all of these. Okay, but when I get to this part, this says that they are parallel, not congruent, but parallel. So these little triangles, these triangular markings do not mean congruent. Those triangles show mathematically that these are geometrically, that these lines are parallel to each other. So why is that important? Why is that going to be significant to us? Typically, especially in this unit, when you see parallel lines, that's going to allow you to add some kind of angles. Remember when we did our dance transversal unit and we talked about all the different kinds of angles that are formed from parallel lines that are congruent? That's going to get you to be able to add some type of congruent angles. And so we've got our given information in the picture. Let's make sure that it's marked. Angle WMR, so WMR, this one right here, is congruent to this one. So of course that's already marked, thankfully. I'm gonna go ahead and check that off. Okay. Then it also shows that those are parallel, which is also marked. And then it wants me to arrive at a shortcut, but there's 2 steps in the middle that will allow me to do that. And so the first thing it tells me to do, it kind of looks ahead and it says, hey, you're gonna use the fact that there are alternate interior angles. So what we're gonna do is we're gonna go to those parallel lines and find where the alternate interior angles are. So if these lines are parallel, I have my students highlight the transversal in a different color. And what we do is we kind of use those arrows as start here markings. And so if you start here, you're gonna go to the transversal and that will create my alternate interior angles. I'm gonna do 2 arcs simply because I already used 1 arc on the other angle M and angle K. So start here and go to the transversal. So those, the ones with the dots, are gonna be my alternate interior angles. So now we just need to name them. So if I name that first one, angle MWR, angle MWR, I need to name that second one MWR, when across the one with 1, then across the one with 2, so that'd be KRW, KRW. Because of the alternate interior angle theorem. Because of those lines being parallel, that's what allowed me to arrive here. If you weren't sure if you did this right, again, just use your congruent statement if it's there. MWR would be second, and then first, and then third. So second, and then first, and then third would be KRW. So double check yourself with that statement. There's no reason not to use it if it's there. So now I have an angle and an angle of one triangle congruent to an angle and an angle of another triangle, but we know we need more information than that. Unfortunately, angle is not going to be one of my shortcuts, so we need more information. And thankfully, the way that this proof is written, they kind of tell you where to go. They say, hey, let's use the reflexive property right here in this step. What does the reflexive property say? The reflexive property says that these 2 triangles meet at this side. So let me highlight that. These 2 triangles overlap at this side. And so I can add congruence marks on that side to say that if I were to break these apart, that side would be present in each triangle, and thus those would be congruent to each other. And so when I write the reflexive property, I can name the first segment however I want, WR. I'm going to say that is congruent to itself. I just need to make sure if this triangle has been reflected or rotated. And so to check that, I'm actually going to use the congruent statement. W to R would be congruent to R to W. And you can tell when you first look at it, W to R, you're touching the angle that has 1 dot, and then you're going across. So whenever you'd go to the other one, 1 dot and going across would be R to W. Okay? So now I have an angle, and a side of one triangle congruent to an angle, and then a side. Notice that side is not included like it was in the previous proof. It's hanging off to the side. It's not happening in between. And so here's my middle stuff that allowed me to get to my ultimate conclusion that the triangles were congruent by a shortcut. So again, right here every time, you're gonna have a shortcut up here. So this is just practice with that. And our last proof is a hypotenuse leg proof, so this will bring us home. I already know that I'm going to need to check for hypotenuse leg because I see right angles. You can use other shortcuts as well that might appear, but usually you're going to end up checking for hypotenuse leg if you see right triangles. That is a very good shortcut for proving triangles, right triangles congruent to each other. Okay, so let's check the givens first. Again, let's just make sure that stuff is highlighted. SP is congruent to QR, okay? And then SRP and QPR are right angles, so of course those are already marked. Notice that they have a step in here that is going to be necessary. Because those are right angles, we get to say that these must be right triangles. If these are not right triangles, then I cannot use hypotenuse leg. So this step is always going to be necessary in an HL proof. You have to say that they are right triangles. So whether they tell you that they're right angles and you have to jump to saying that they're right triangles, or whether they tell you that they're perpendicular and then you have to go from perpendicular to right angles to right triangles, you have to somehow say that they are right triangles before you can use hypotenuse leg. So I know that I just have this other step that I'm missing in the middle. Like I'm just missing one pink step in the middle that's going to allow me to use HL. So let's check this real quick. I've got everything on the picture I need. But again, when I look at these, I always ask, do they overlap? Is there any information I can add either from the given or from overlapping triangles? And these do. These overlap at a side. So I get to add 2 tick marks there to show that if I were to break these apart, that pink segment would be present in each triangle. So I get to say by the reflexive property, which they actually can tell me. You can kind of look. That's the easy part of this proof is that they have some of it filled in for you to get you used to these proofs. The reflexive property would say that PR, if I name it that way, PR, that is second and then third, is going to be congruent to RRP, second and then third. So again, this one has been rotated. I know that sometimes things have been reflected, and so y'all get to say PR is congruent to PR, but because this one has been rotated, this has been rotated around, you have to rotate that as well. So just look at the congruence statement if you need help with that. That's also written up here. PR is congruent to RP. And so why does that work? If I read that correctly, it looks like side-side angle, but it is not. We're talking about right triangles here, and so I'm able to use the HL shortcut. So hopefully that helps you a little bit, just kind of looking at this given stuff in yellow, the in-between part, which I think is the hardest part, in pink, and then ultimately what you're trying to prove in blue with shortcuts listed next to it. Hopefully that helps you a little bit, and our homework is going to be just trying through proofs to see what you can do with them. Again, we're going to keep practicing these, and we'll get better and better and better at them. I hope you are having a fabulous day.